want to present today how we can make a parametric reverse engineering of long-range scanner data from FARO. And first of all, I'd like to show a presentation about what kind of application we have in that field. So now you can see the first slide of our presentation, 3D parametric feature modeling from long-range 3D scan data using Rapidform XOR, parametric CAD models from 3D scan data. Okay, first of all, let's have a look at the complete process. Actually, normally we go from scanner and capture the scan data, and this is the FARO scanner we are handling today. And then we gather the design intent, or we gather the features from the 3D scan data using many sophisticated algorithms and features, and then we can create a parametric history tree. And then we can create this CAD model and transfer the CAD model to Pro Engineer, SolidWorks, Unigraphics NX, to main CAD applications. Actually, the traditional reverse engineering software had some problems in the past. That is, when you have a CAD system and you need scanned data into the CAD system, then you have a problem that the CAD kernel cannot handle very much data, very much point-size data, large-size scan data files. Then the next thing is, if you generate a NURBS surface, and the NURBS surface is in the CAD software not very easily to handle, because you can only extract some shape and you cannot modify it later. The reverse engineering software is useful only for extracting feature profiles. Mesh generation is necessary to extract the NURBS surface. You need to smooth the mesh, because if you don't smooth the mesh or fill holes, then you have all the problems from the mesh you have also in your surface. And the mesh optimization is the most time-consuming job, actually. Then IH's file format, or the step file format, neutral file format, is limited in usability. If you need to assemble multiple parts, then this is a very tedious, difficult way. And solid modelers are limited, so there is no automation. You cannot detect, for example, patterns or something like that. You have to do everything manually. And normally you have no tools to quantify the model accuracy. So you just reverse the surface, and then you transfer to CAD, and then you can estimate how accurate your reverse modeling was. And then there was the invention of the third generation reverse engineering solution, which started with Rapidform XOR, actually. In Rapidform XOR, we have a huge number of point clouds and meshes to handle, and we can extract the intelligence from the scan data. That means if you have scan data, then the plain scan data of the mesh is just information of triangles in space. So it has no information about features. But with a sophisticated algorithm, we can segment that mesh into curvature changed areas. Then you can extract feature information. And extract feature information not only, but also extract pattern information, or extract numeric information from the 3D model. We can work with real measurements, with real dimensions. Then it's traceable and fast. We are able to do 3D modeling directly from point clouds or from meshes, so we don't even need to generate a mesh. We can also work from the point cloud directly. We can create solid surfaces by using a CAD engine. So we actually implemented the Parasolid engine, and we are using our own NURBS kernel as well. So we have both methods we can combine. Then a real-time quantification of model accuracy and quality is possible. We have an accuracy analyzer that is a tool with which you can, at every time of your modeling process, you can visually see how accurate you are doing the reverse modeling. And then, at least, we have the downstream exporting. That means we can live transfer to native CAD applications. And during the live transfer, the whole history keeps intact. Okay, so 3D parametric feature modeling from scan data. What can Rapidform do? Here is a basic workflow. We can actually create fully editable parametric feature model from massive point clouds and meshes. That means if you have a long-range scanner format, any format, then you can import it in Rapidform XOR, and you can start reconstructing from that scan data faster than any other reverse engineering approach. Actually, we can easily handle large number of point clouds. We have a sophisticated algorithm which dynamically manages the computer memory. And we can capture the design intent, actually. So if we measure a value from the scan data, which is 3.95 or something, then we can also change that value in Rapidform to resemble the design intent, and then we can change it to 4.0, for example. Then we have a seamless interoperability with other CAD systems, as I said before, like AutoCAD, SolidWorks, Siemens NX, Pro Engineer, and CATIA. And below here you can see the basic workflow. We do the scanning, then scan data editing. It's a very short, actually, automated scan data editing. You can also do manual editing, but we have an algorithm that handles a lot of scan editing jobs for you. Then extracting design intent. So you can extract sketches or values like fillets or even pipes and beams. You can extract from the scan data. Then you can do 3D feature modeling and then export it to downstream. And we have short video clip here, which shows the process. So here you can see the 3D scan data actually from a long-range scanner, and it's a bridge model. And now we go into Rapidform XOR redesign and import the scan data. And here we have a function you can walk through that scan data as if you use a plane. And during that whole operation in Rapidform, you can always check some geometry and extract some, for example, cylinders like the beams or sketches. Then you have different methods to show your scan data. For example, use a height map. And a very powerful tool we have is this mesh sketch setup. Actually, we cut the scan data at the specific position, and in this case, we get cylindrical shapes as a cross section. So it's basically a circle, and then we can just drag a frame around that circle and just capture the circle information. Or we can also use arcs and any other CAD sketching functionality we can use in Rapidform. And that makes it powerful because once you did your modeling job, then after that you see, oh, I need to alter something. Then you can go back in the step and alter a value, and then the whole model reflects your change, actually. Now we are doing some extrusion. Then you can already see the pillars are growing. And then the next step is some other feature below the road of that bridge. So in the 2D sketch, we have all the constraints which you have in the CAD software as well. And that way you can easily combine point cloud handling and CAD operations. So in this case, let's see the bridge itself. In this case, we will just make a partial mesh of this to get the profile of the bridge. So this is the profile, and it's actually not a complete profile, but there is a pattern in the profile, and Rapidform automatically detects if we have pattern information, then we can use that pattern information. So every time you have a repeating process, you can also repeat that process automatically in Rapidform. And there you go. So almost finished, just a little bit at both sides, and that's the bridge. And here you can see the accuracy analyzer, this color deviation checking, or surface quality checking. And everything in here is parametric, so you can also go back and forth and transfer. In this case, they transfer to AutoCAD. So there's the bridge. Okay, on the next slide, there are some different applications we will just briefly go through. We have installations in the facility planning, or for building designs, for reconstruction, for automotive or shipbuilding, aerospace, defense, heritage, and survey as built. So the bridge which we saw before. Okay, now for the application gallery, the facility planning. This case is a chemical plant actually, and there are some oil and gas plant, sorry, and there are some pipes and tanks and beam structure, and also here we have some video clip. Okay, this is a high density point cloud. And from that point cloud, we can start and create a CAD model. There are many automated things, like, for example, this linear pattern. So if we create just one beam, then the same beam is multiple times in the model, then we can just make a linear pattern to create the same beam again. And then the rough structure is built up very quickly, and now we're going to extract some cylindrical shapes or some pipes. So this is basically the process every time with facility planning. Actually, here is another one, which is a large-scale iron foundry plant. This is actually very impressive because the huge size of this foundry plant. If you see the video clip, I think this one is just a part of it, but we have another, let's see, another video clip. There is a complete view from one side to the other. And here you can see the detail we can extract from just from point cloud, like stairs or I-beams or pipes or even machinery. Everything can be extracted from the point cloud. I got a question from Andrew Maltby. Actually, I'm not aware of software called Revit. Maybe you can explain a little bit more to then, or just email some information about the Revit, then we will see whether we can support it. Actually, normally we can support any neutral file format, like many file formats actually, like NURBS file formats, STEP or IGES or Parasolid, and we can also support mesh formats. So yeah, if you mail me some information about the Revit software, then I will check whether we support this software. Okay, this one is one of building design. And here is the modeling process. Actually, here we get the scan data. This is already a mesh. And what you see here, the colorful regions, that are the curvature regions, which I mentioned before. So when you hover the regions with the mouse, then you can see what is the curvature behind the mesh. And then you can extract planes or freeform shapes or cylinders, spheres, torus, cones, whatever. And in this case, we are doing mostly 2D sketching and extrusion. And also in case of 2D sketching, we have the pattern functionality. So you don't need to use line drawing for every line. So you can also use pattern function like in any CAD software. Okay, I will cut this a little bit. This is basically just extrusion, sketching extrusion all the time. And let's have a look at the final model. So this is how it looks finally. So you can see there is very much detail in it. You can get everything out of the scan data, even the small features. Okay, I will not show every movie. It's basically the same thing every time. So in this case, we have some old building design or some reconstruction of some already worn building architecture. So this is quite interesting. This is a car body, which is reverse engineered, also from long-range scanner data. This is actually, again, a mesh. This is put together from many long-range scanner data files. And here we are using a solid modeling approach, but actually it's a hybrid modeling approach. So we are using solid modeling and we are using surface modeling as well. And Rapidform is capable to combine both modeling variants. So you can cut solid by surface, or you can also create a closed surface set, and each closed surface set is considered a solid body. Or you can delete one face from a solid body and then you have an open surface set, so you can go back and forth. In this case, we are making heavily use of our redesign assistant. The redesign assistant is actually every time you pick some magic wand button in Rapidform, it is guessing a value from the scan data. So if you extrude up to a certain region, then it is guessing the extrusion length. Or if you apply a fillet, even a variable fillet, for example, then it is guessing the fillet diameter or fillet radius in this case. And it is estimating this from the scan data. And then you have the possibility to change the value again. So everything you are doing here is parametric, and you can go back and change it until you think it is okay or until you like it. In this case, we are using sweeps and lofts and extrusions. Now this is the surface modeling approach. Actually, now we are doing several surface sets, and then we are combining them, and then we cut a solid model by surface. The windshield and the hood, and then cut again. And you only need to reverse engineer half of the car because the other half is symmetrical, then we can also detect in the scan data, we can detect a symmetrical plane. And then we can mirror the model about that symmetrical plane, about the mirror plane. And in this case, what is really interesting that we don't have very much scan data. We have very much holes actually, but we can capture the design intent. So we don't need to scan the whole part. We need only to scan the part which is defining the features in the model. That saves us time scanning, and that saves us time in preparing the scan data for reverse modeling. Again, I have a question about the live transfer. Actually, unfortunately, on my computer, it's a notebook. Actually, I don't have the CAD licenses right now. But if you like to see a live transfer, then we can make a web demonstration, and then we can arrange something where we can show you the live transfer. So at the moment, I cannot show the live transfer. I'm sorry. Okay, this was the car body. Then we have several other car body cases. For example, one which is more freeform. This is not as blocky as the previous one. And this one as well. Or a boat. This is also an interesting case, actually. Actually, regarding the live transfer to AutoCAD, actually we don't transfer every feature to every target application. That is because Rapidform can transfer the model into 4 or 5 different applications directly on the, when they are on the same PC, and therefore we have to have the functionality which is in all the 5 target applications. And this functionality is not made by us. This is actually made by the target software packages. So if they open up their API to us, then we can implement this live transfer for this application. And in case of SolidWorks, we are a Platinum partner, so we have a very sophisticated live transfer to SolidWorks. Then in case of Unigraphics, we are using the same kernel, like Parasolid is also used by SolidWorks and Unigraphics. So the same kernel is very easy to live transfer. In case of AutoCAD, AutoCAD is using a different kernel. And in that case, if you have AutoCAD on the same system, but we can transfer the file to AutoCAD. But however, it is not fully parametric. So this is the boat model. Then we have the aeroplane model as well. Okay, so to show again the pattern is this tank model, for example. You don't need to do the whole chain. You can do one piece of chain and then use pattern along a curve to create that chain, and then use mirror function to copy over that chain to the other side. So I won't show that video again. So it's basically a similar process. But we can also do freeform, very much freeform shape models like sculpture, and this is also quite interesting. This is, I think, a gypsum or wooden piece of art, and that was also scanned as a point cloud, then triangulated. And in that case, even though it has holes, we can use some parametric way to complete the part behind, for example, and then use some organic algorithm to complete the part in the front, the head and leaf structure. In this case, we are doing a little bit mesh handling, mesh healing, for example, to correct some mesh errors. Then we have the remeshing tools like rewrapping, and then you can see also if we have mesh with holes or mesh with defects, then we can also create a very nice looking mesh. Okay, in this case, that is a cultural heritage model, a tower which was exported. And again, the bridge, we already saw that at the beginning. And the subway station. Okay, so we generate engineering-grade CAD models from billions of points. That means we have no hardware-coded limit of point handling. That means if you have a powerful computer, then you can load almost any scan data size to your computer. It's only limited by hard drive and computer memory. And we use real-time rendering. We use some shaders, and we use some dynamic view. That means we reduce the number of displayed points. If you have a huge scan data which you cannot handle very fluently, then we reduce the number of visible points which you don't need. So you can still see the model, but you can move it quite fast. We can clean and align scan data. We can use solid and surface modeling tools using the CAD engine, create solid and surface features, feature creation wizard from scan. We have meshing tools like create, clean, optimize polygon meshes, and we support color. I think in the first video you saw the bridge. There was the color mesh, color point cloud. And we also have the QA/QC tool. That means we can also check the deviation between the scan data and between the reverse engineered model. Or if you do a CAD refit and you already have CAD data, we can import the CAD data and import the scan data and compare. And then where the CAD data is deviating from the scan data, then you can locally redesign the CAD data to fit the scan data again. And we can do native CAD model export for AutoCAD, SolidWorks, Siemens NX, ProEngineer, and CATIA. In case of SolidWorks and Siemens NX and ProEngineer, it's fully parametric. And in case of CATIA and AutoCAD, we support some native file format, AutoCAD and CATIA, and we support the Solid and the Sketch, and that's it. Okay, now that was the PowerPoint presentation. And I would like to show you some real modeling in XOR. So I already loaded some scan data, and I already created some regions in the scan data. This is actually, let me hide the regions and hide the solid surfaces. So this is basically the scan data. This is scanned by a long-range scanner. You can see it's a long-range scanner. The long-range scanner was positioned here. You can see that minimum distance radius of the long-range scanner, and you can see some long-range scanner typical mesh resolution widening in the far area. And in this case, we have a corner of a industry hall with some piping and some walls. And now I already created some structures from the scan data, which looks like this. And this one is really CAD, so I can show you some quality. This is really CAD model, planes, and in this case pipe or extrusion. Then let's see the deviation. Actually, when looking at the deviation, you have to see the minimum and maximum deviation. I think I will go to 5 millimeter. So in that case, this is capturing design intent. We can, okay, Danny Celis asked, can we separate the object with layers? Actually, we don't have layers, but in the Rapidform we have a model tree and we have a feature tree. So in the feature tree, this is our timeline, where every modeling feature comes after each other and has dependencies to the parent feature and to the child feature. And in the model tree, we have a categoric listing of each feature, of each object. So when I hide, let's hide this one. So then I can go into the surface bodies group. Then I have only one surface body because I combined it already. And let's go in the solid bodies group. Then I have actually multiple solid bodies. So this one is one solid body, and this is one solid body, and this is one solid body. And you can, of course, use different groups of bodies, and you can also hide them and show them. Okay, now we want to see some real thing, what we can do. We can do this in many ways, actually. Let's just get some easy cylindrical feature. For example, like this. We can use a pipe wizard. Then we can just click this feature, go to the next step, and then it shows us this would be the pipe. We can cap the ends and we can choose we want to use freeform curves or we want to use lines and arcs when possible. And we want to use, this is a real cylinder, so I pick this target curve and I say I want to have only 2 points at the bottom and at the top. And then I create this one. And now this is our pipe, and I can also use the parametric history. I can double click into my sketch, and then I can, for example, extend this line, and then also my pipe is extended. And that works in not only piping, that works in other cases as well, like this one. Or yeah, let's do with this one. We can use a mesh sketch. And this mesh sketch is actually a plane which we shift through our model. Then you can see we make a section through our model. And in this case, I make a section here. And I make a section here. And I make a section here. And then I have this flow of my, what is this, cable duct. Like this. I can just pick a part of it like this. And then I can trim. Okay, and then I can show my mesh again. And then I can use extrude. For example, in this case, I'm extruding a surface. And then here it is. And now I have a second surface. Now I will hide the first surface. And Now I want to see my model without the roof, so I'm using view clip. So I can go into display and use the view clip and set it on a plane, on that plane. And then I can say I want to see only this part to look from above. And then in this case, I want to have another sketch, mesh sketch actually. And that mesh sketch cannot do only sections, that mesh sketch can also do silhouettes. So I can go down a little bit until here, and then I can drag a silhouette. From which side we are looking? Okay. From this side. Okay, and now we can just drag a frame. And I'm just snapping my lines to my scan data. Then let's look at this. Okay, here we have not very much scan data, but we can see there's a trend from here to here. And then I can measure the distance here. This is a redesign assistant actually, so it measures 296 point something, then we say 296 for example. And then I can define an offset from this into the other direction with 296 or probably 300. So I can make this the same distance. 296 and here again 296. 296. Snap it again. And now we can use power trim. We trim the corner, this one to this one, and this one to this one, and from here to here, and from here to here. And then we can delete this. Okay, and now we can trim with this tool, this target, and now we can keep this middle area, and this is basically our duct. Then we can use thicken to make a thickness. So we go, let's say 10 millimeter, or maybe 20. In both directions, and there it is. So that way we can complete many of the features, not only pipes, also rectangular features or freeform features. Okay, that was actually a little bit over the 45 minutes, and now I like to ask for some more questions. Okay, I see in the Q&A panel can Rapidform handle airfoil surfaces? Okay, yeah, we can also handle airfoil surfaces. Maybe in the PowerPoint there was one application. Let's see. So actually this is not a real airfoil surface case, but we can also handle airfoil surfaces in a similar way like this. We are using basically loft, and we have a loft wizard as well, so we can generate multiple sections through the airfoil. We can also generate sections along along a plane, facing a plane, or we can create sections along a curve. So if the airfoil is bent, then we can also define a skeleton curve, and then along that skeleton curve we can create the loft sections. And the loft wizard also supports us with two methods based on accuracy. That means based on a maximum allowed tolerance to the mesh, or based on number of sections. And after the number of sections selection, we can also see a preview. And if the preview does not yet enough match the mesh, then we can also alter the sections and add another section, or move the sections in an interactive way. And of course, we can also use, in case of simple airfoils, we can also use sweep surfaces to generate CAD-like surfaces. Like this rudder. Okay, in Rapidform we have a user guide as well. I will show you. Once you start Rapidform, you can go to help always, then you have the context help, and you have a tutorial. We have actually many tutorials from many fields of applications. This one, like CAD modeling, part design, then we have a movie, and we have a document. And mesh modeling, mesh optimization, we have movie and document all the time. Solid modeling, bridge design, part, hybrid design, sheet metal design, auto surfacing, freeform design. So from every field of application we have a tutorial. Like a movie, let's see, hybrid design, movie. And this movie is actually recorded within Rapidform, so you can directly follow the modeling process. Oh, look at this. This is already airfoil. Let's see a little bit further. This is actually the base solid, which is created here, and the base solid as rotation. And now, okay, from here, we are coming from fit from points. We get the virtual edge, it seems like. Oh no, it's the trim line. Okay, the trim line between the leading edge and trailing edge. And now, based on that lines, we generate sketches and using splines, and then use the loft. So that are basically our tutorials. And we also have in the help file, we have the quick start guide. So in the quick start guide, you can use your own modeling pace to learn your Rapidform XOR modeling. For example, use this one, and then the first page is showed what you can do in this chapter, and then you can. Okay, let's hide the other mesh. Let's just open a new one. Quick start guide. Go here and import the file, and then you can just follow the instructions. And once you don't find a function, then you can also click highlight it, and then this function is highlighted, so it's very user friendly. What is the recommended RAM to run Rapidform? Actually, that depends. Actually, the number of polygons or point clouds, this is a very low res poly model with only 65,000 triangles, 33,000 points. You don't need very much, but if you have, let's say, 1 million points, then for example 1 GB RAM. But if you have 300 million points, then you might need maybe 8 GB RAM. And now the question, why is it that difference? Because we are using some loading, unloading process. You can right-click the mesh and you can click suppress. And even the mesh is suppressed, it will be still calculated, but it's cached on the hard drive. And only the points which are necessary for visualization are shown. Can we download more tutorials? Actually, there are also YouTube movies about Rapidform, and we have also tutorials on our website. You can find them in the support section on our website. And also there are some demo movies actually from Rapidform XOR, XOB, you can find in the product chapter of our website. Okay, there are some questions about resale opportunities. Actually, we have a reseller application form on our website. So I think if you go to partner, then you can see, let's see this. Support, Rapidform, partner success. So this is the Rapidform partner success portal, and you can also apply as Rapidform partner, and then you can also apply for the resales. Is Rapidform XOR widely used in biomedical engineering design? Actually, we are in almost every field of application, also in the field of maybe teeth or implant or any also organic shaped field of application. We can use as well the second generation reverse engineering based on just mesh and mesh cleanup and then NURBS curves and also NURBS surfaces. And we can also use the third generation reverse engineering based on CAD modeling. Do you have any examples of topographical terrain data? Actually, I have to check the database. I don't know it from just from my mind. I have to check the database. But I'm sure there will be some topographical terrain data as well. What kind of computer we need to use scanning well? I recommend a workstation. As you can see in Rapidform XOR, we are supporting multi-threading. So let's see my old model. So when I go to check the deviation, okay, I have to show everything. Then you can see at the bottom there are many progress bars. At a time when progress is splittable into several threads, then we also use several processors. So in my case, I'm using a notebook which has 8 processors, so it's fully multi-processing capable. And I wouldn't use that is good for this one. It's NVIDIA, and in my case, I'm using the i7 processor. On there is more info on the minimum requirements. Okay, then if there are no more questions, then I like to thank you. Yes, a demo is available as well, and you can also apply for a web demonstration, so we can do a one-on-one web demonstration with your data as well. There was one question left. I'm interested in generating good triangle mesh from point cloud or STL file, or generate step file from the point cloud or STL file. Do you have this capability? Yes, of course. First of all, triangulating good quality mesh. We have several functions like the mesh buildup wizard. The mesh buildup wizard is capable of triangulating from multiple point clouds. So it's like a batch process. You can align and then triangulate all the mesh together. And then we have a wrapping functionality, a rewrapping functionality, which closes also open holes in the mesh and repairs triangles. And yeah, that is one method to generate the very good mesh. And then the second method is some enhanced feature. Maybe I will show you this one on small sample data in the quick start guide. Yeah, let's just use this one. And as you can see, we have some defaults in the defects in the mesh, and the mesh is quite rough. And when we double-click the mesh, we can enter the mesh mode and edit this mesh. And then we have this function, enhance shape, for example. With the enhance shape function, you can recalculate the mesh based on curvature. That means in the high curvature region, it will keep the high curvature. In the low curvature region, it will reduce the noise. So you can get more sharp edges and more nice looking surfaces. Like this. Okay, there is one more question. Paul Casson, is there a connection to PDMS character limit? What is PDMS? PCDMS, you mean, probably. Okay, Aviva plant data management software. Actually, I don't have heard about this software, but maybe we can talk about this more. Maybe there is a file format we can support for this software. Okay, then I want to thank you, everybody, for attending this web seminar. And the remaining questions can go to tobiask@rapidform.com. And I try to answer all of them in cooperation with my colleagues in EMEA office and in the Korean headquarters. Thank you.